Hi and welcome back to my Tekkit tips series, and in this episode I'll be looking at this. This is my attempt at creating a functioning lift system in Tekkit. And if I bring up the remotes and bring up the descent, I can trigger off this lift descending automatically like that at a distance. I missed the floor. At the moment it isn't computer controlled, it's simply an on-off descent system, pretty much like you'd have had with an old bellhop, having to actually pull a handle to tell the lift to ascend or descend. It's 12 stories high. The design criteria that I set myself for this is it has to start at bedrock, which means it can't have anything below the lift to any significant degree, and it doesn't want anything visible above the lift, because in my Let's Play world this will either emerge onto the surface or into the base. Haven't quite decided which of those two it will be yet, and therefore anything above the lift would look very ugly. So this is about the minimal functional size I could come up with that you can stand in and still get around. And we've just about finished descending down to the bottom floor. There we go. So we stop that, and there we go. That's what the lift looks like. Now, deliberately, as we descended there, those paying attention may have noticed that some of the floors are a different height. That's because it's not going to be built on the basis of stepping a fixed number of blocks to get to each floor. It has a feedback mechanism built in, where the computer will be able to tell which floor the lift is at and which direction it needs to go. So the other thing I've done, just as a nice little feature I thought, was just like in a real lift, it has a hatch to get into the lift shaft at the top. So how does all this work? Well, first of all, this is the Lyft Car, and this is a fairly self-contained unit, this 3 by 3 by 1, 2, 3, 4 block square here for the car. This is made up of support frame blocks, so the bottom 9 blocks are support frames with wood covers over them, and then these at the corners are also support frames, and at the top we have another frame, in this case 3 by 3 with the middle one missing of support frames. And then to get these panels here, these are panel blocks rather than cover blocks. You can tell because in this texture pack they have the little corners on, and that allows that frame block to still hold the panel or the cover, which is then there. So that glass is either held by that frame or that frame, it doesn't matter which. That one's held by that one's held by that one, and similarly at the bottom. This one is therefore held by that one is held by any of those 3 around it. So I can't get rid of that one, because then this block wouldn't have any frame holding it. Now you could just get rid of the front, make it wider, but I preferred this look. But yeah, that's the basic car done. So down below into the engine room, as it were, for the lift. Ta-da! This is what it looks like. So it's relatively compact. As you can see, bedrock is there, so nothing could descend below that. So I can't have, what would be the simplest thing would be just a long shaft of support frames which it moves up and down and just descends out of sight below the ground, because there is nowhere for that to descend to. So instead what I've had to employ is this and this. That is a block breaker, and that is a deployer. So this frame supporting the lift and pushing it up and down gets created and destroyed dynamically as and when needed by the lift. So let's show it working first of all, because it's a lot easier to then explain how it works. So I'll get back to you in a second, hold on. Yeah, sorry about that. I just been messing around with the number of frame blocks that was needed in the system, and I must have accidentally put something in there which shouldn't have been, which then of course broke everything. So ignoring that little glitch, yeah, so as you can see, this shaft gets created as the lift ascends, And if I stop it and start it descending, you can see the blocks are getting destroyed by the block breaker as it's descending. And what it does is it returns them through this pneumatic tube into the deployer there, ready for the next time it needs to ascend. And that deployer has a nice stack of support frame blocks in there, ready to ascend to the highest level that it needs to. So I'll stop that descending. So nice and simple. This is the wireless signals coming in. So there's a wireless receiver there on channel 1, which is the one I use to go up. So that's that one. That is connected to a toggle latch, which what that does is as soon as it receives a redstone signal, that little lever that's built into that block effectively switches from side to side and outputs to this side or this side, depending on which way that lever's switched. And then we have a timer, and the timer stops when it receives a redstone signal. So because this is currently switched this way, it's stopping that timer going. So when I trigger a wireless pulse, this switch gets flicked to the other side, so it's now outputting on this side, which is going nowhere, and the timer is no longer receiving a redstone signal, so it's going. If I trigger it again, this gets flicked back over, the redstone signal is then going to the timer and it stops it. The timer is set to pulse at, if I can get in there like that, 0.8 of a second, which is what I've found to be the maximum speed I can go in this single player world and to have everything work reliably. You may find if you're doing this on a shared server, you'd have to slow that down slightly, but 0.8 of a second seems to work fine for me in this world. So that's it for the Ascent signal coming in. Similar system for the descent stage. So on this case, it's ID 2. So you can see there 2 on the end. That does the same thing into a toggle latch switch into the timer, which is again set at 0.8 of a second and comes in here. Those signals then, so if we start with the Ascent one, because that's probably the simplest one, comes up here and first of all triggers the frame motor to switch. So every time that timer goes around the loop, every 0.8 of a second, it tells the frame motor to shove everything in that pile up the lift shaft. So that frame motor is what drives the lift up. So every tick of the timer, signal comes up the green wire there into the frame motor and pushes the lift up a step. But then of course it would run out of frame blocks, so it also, the green wire is also connected to the deployer, and every 0.8 of a second the deployer will attempt to create a frame block in front of it. Now what it tends to do is it either creates it there or there, and that works fine because either way the frame motor will grab the next one along. So it seems to prefer to deploy it there, but if it gets a signal and there's a block there, it will add one there, and that's fine because the frame motor will then grab it the next time up. So that works absolutely fine in this vertical configuration. So that's basically it for ascending. Descending, so once this isn't ticking anymore and this one starts to tick, so let's start that one going. So you can see the signal comes up there. That tells this frame motor to drag everything down, and it also sends the signal into this pneumatic tube. Stop that a second. This is redstone pneumatic tube, and the good thing about this is not only does it respond to a signal itself to pull blocks out, but it actually passes that signal through to whatever it's connected to. So this is a tube and a wire in one, which is a great tool to use. So that wire there doesn't need to continue round to the block breaker because this pneumatic tube, this redstone pneumatic tube, does the job of the wire and the tube. Problem is, if that was also connected to the deployer would also be getting a signal. So you need there to have normal pneumatic tube for that block to prevent the redstone signal also going to the deployer when you're trying to descend. So the signal comes around here and into the block breaker and also the pneumatic tube. So each step down, oh, it's already down, can't descend any further, so let's just ascend a second. So as it descends, each step down, it steps down on the frame motor, the block deployer grabs it, and also this redstone pneumatic tube gets a signal to grab the blocks out of the block breaker and move them round back into the deployer. So you can see back blocks are back in there. So let's stop that ticking. There we go. Okay, that's basically it. There's a few gotchas to look out for. And firstly, this redstone tube here goes next to this frame motor, and if it wasn't for that glass panel or glass cover block which I've put in there, it would also pass its signal to the frame motor, and that's the frame motor to Ascent. So without that glass cover block, it would be sending a signal to the motor to descend and then to the motor to ascend, and the lift would be bouncing up and down. The other gotcha is it also needs a glass cover block here. This is the block breaker for the descent, but this is the wire for the ascent. So without that cover block, every time it toggled to try to ascend, it would also be trigger the block breaker to destroy the blocks. Now usually that would be fine, except for those occasions where the deployer has deployed a frame there, where this block breaker would then grab it erroneously. So it also needs that cover block there to prevent those two joining. And that's about it. The other gotcha is this one. Because this outputs a signal on either side, sorry, the timer outputs a signal on both sides, or actually all three sides. I think when it pulses, it outputs on that side, and that side. If you had a block there, it would be acting as an input into this switch, which would actually tell it to toggle, and that would be annoying. So you have to have a gap between them, or otherwise isolate those. You could arrange them differently to get the same result. Lastly, this could be arranged more compactly. If you're paying attention to what it does, then this block breaker could be here underneath the deployer, and then these two tubes could just connect directly between them over there, and we wouldn't need this run of redstone pneumatic tube round here. They would just be able to have the single one connected at this point to send the blocks between the two. However, when I tried that, all of the frame blocks were disappearing. The block breaker was destroying them, but it wasn't managing to send them out the back into the deployer. And this had me stumped for ages. I had all this working, but it was more complicated because I arrived at it in a more haphazard way. And I simplified it, and it wasn't working. And it took me ages to figure this out. So I did a quick trial out here. Can't get out. And in this system, which is a test system I'd got set up, it works. So this deployer here is deploying support frame blocks. The support frame blocks are getting pushed along by the frame motor. The block breaker is then breaking them and moving them through the pneumatic tube back into the deployer, and none of them are disappearing. You end up with the same number at the end as you started with, which is fine. However, when I first set this up as a test, I created it facing that way. So this block destroyer, instead of facing this way, which works, was facing this way. And in doing that, if I tried to step it at anything like this rate, it was just losing blocks. It was not consistently spitting them out. Now, I haven't done any further investigation to rearrange this again, make sure it's still doing the same things, but it appears to be a north, south, east, west glitch. So with this block deployer facing west to east, everything works fine, and facing from north to south, everything seemed to be wrong. So that's a gotcha to certainly watch out for. I can't vouch that it's absolutely certain, but it certainly seems to be. I think that's it for the gotchas. The last thing is the computer. So in a fully blown system, this would be tracking where the lift is and which way it needs to go and who has called it to which floor it needs to go to next, all of that sort of things, which is a fairly standard lift program. And the way it works in this build, I haven't written the software for it yet, but I will do, is there's a redstone lamp on the bottom of the lift, which is connected to a panel, so it gets dragged up and down in this gap with the lift, and on each floor there is a wire which it gets a signal through a bundled cable to back down to the computer. So each floor has its own unique color. So that's yellow, next one is pink or magenta, can't tell which it is, next one is light blue, etc., all the way up to the top. I think dark blue is the top one and white is the bottom. It's in order of the colours in here, so white, orange, magenta, light blue, etc. for the floors, so they correspond to the binary values. And the computer is just running a very simple program. I'll just show you briefly what the program is, just in case anybody's interested. So this is the program that it's doing. So it basically just redirects the output to this big monitor, and doesn't need to print test one, that's pointless, that was from debugging. And then just in a permanent loop, while true, clear the screen, set the cursor to the top left and run the red probe command. Anybody that's followed my Let's Play series will recognize this bit of code as basically the same as what I was using to monitor the inputs in the factory that I'd got. There we go, so it's now running again. And if I set that ascending, you'll see the computer monitoring the inputs. First of all, it's getting no signal because the lift is between floors. As it passes the next floor, it goes orange. That would be a trigger to the computer to know the lift has reached a particular floor or which floor it's on. And that's basically it. So there we go, a pretty functioning lift system, nice and compact. And the next thing I'll probably be doing is implementing this in my Let's Play world and then continuing the programming for it in there to actually allow you to go to the lift on any floor, press a button, it'll call it from whichever floor the lift is on to the floor you are on, and open the doors with pistons, let you get in, and somewhere you've got to be able to select which floor you need to go to. Now I think ideally I would have it where there's a computer actually in the lift with you that you can use to select which floor you want to go to and to give it a nice user interface, etc. Whether I'll be able to get that to move with the frame in the lift and still connect to the outside world, not sure, because the computer would need the wireless modem on it. All of those blocks will need to be connected by frame in order to move with it. Could be a bit of a challenge, so it may need to have a computer outside the lift on each floor instead, but the ideal would be to have a single computer terminal in the lift with you that moves with you where you go and tells you which floor you're on, all that sort of information. So that's it for now. I hope that was useful. Hope anybody found it interesting, and see you next time. Cheers.